having some cooling issues with my 1964 Mercury, and I'm going to solve it using this. 1964 Mercury Monterey convertible with a 390 FE engine and FiTech on it. And I am going to try to make the cooling system a bit more efficient, get rid of the last real issue I have with cooling. So what I have is, when I got the car, the radiator was leaking, so I was looking for the Champion 2 core, but I ended up, all they had in stock was the Champion 3 core. It has a very skinny shroud, nice low profile, pulls a lot more air than the junk fan that came from Champion. I went to a 3G alternator to power the fan, and I'm using the Edelbrock fuel pump, which is, I have here, I removed one horn to put that in there. And in the shroud too, I have these spall flaps so that at speed, I don't get air trapped in here in this very small shroud. So these will open up and there's holes drilled behind there. Air can push right through. The problem I still have, going up a hill on the interstate at about 70 miles per hour, really pushing, the temp will start to climb up to about 200, 205, and I really haven't pushed it far enough to see how far it was gonna go, but I have a 180 thermostat, and I would just like a little better control than that. What I found with a temperature gun was that at the water pump, all the hoses are suction. It's pulling coolant in through the bottom radiator hose and the heater hose and the bypass. All of those are pulling in coolant, and it's pushing coolant into the block, the coolant, in through here. Now, to explain what I was seeing with the temperature, out of the thermostat, I was seeing about 195 on a 95 degree day, just idling in the driveway, about 95 here as it's entering the radiator. Now, at the bottom radiator hose, I was seeing about 175, so it was cooling the coolant down by about 20 degrees. However, the bypass and the heater, because the heater wasn't running, and there's no stop in the heater hose. There's nothing that turns it off when the heater's not in use. So these were both at 195 degrees as well. So you have this and this both adding full temp coolant back to the water pump, which is pushing it into the block. Now right here on the water pump, the best temp spot I could find to approximate the temp of the coolant going into the engine was about 188. So I'm cooling it down to 175 and heating it back up to 188 before it goes into the engine. Just doesn't make much sense to me. Now, I think part of the problem is, or why I think you sort of have cooling problems, I think several people do when going to aluminum radiators like this, is that the water flows on resistance. So it's not so much the size of the hose, it's how much total resistance is in the system. Now, I believe these may have more internal resistance to them than the old brass radiators, which will cause more of the flow to go through the bypass and the coolant hose. I have no proof of that. But either way, you have two 5/8" hoses dumping hot coolant back in, and I'm going to cut that in half. The way I found that I'm going to do that is with this little guy. This sells from, I think Vintage Air sells this, and what it does is it shuts off electronically. It's made for when you turn the AC off to turn off the hot water. So what I'm going to do is put this in line with the heater hose, and because I have the FiTech power adder, it has two fan circuits. So I'm going to wire red's always hot, black is ground, and blue is the control that actually closes it. I'm going to wire that to the trigger for my second fan circuit. So when FiTech says the engine's getting too hot and we need a second fan, instead of a fan kicking on, it's going to close this heater circuit and help the engine cool if it's getting too warm. Now to test it, I set the FiTech Fan2 on to 145. Current coolant temp reading 172. And if I get right in there, they're 174 now. But my heater hose line here, 140. It got up to 140 and it just stuck there because I'm not getting circulation back through here. So even though the engine's warming up now, I'm cutting off that flow. Now that was just to test it to make sure it was cutting off. Now what I'm going to do is raise that back up to 200 degrees, and that'll give me a little bit of a safety net as the engine starts warming up.